Hello, hello, hello. If you're watching this, you missed day 1 of week 20 of Computer Science Principles. We are nearing our final stretch here for the semester. This was a shortened day, so this video will be also short. We are continuing our exploration of loops. Go loops. Let's take a look at what we're about here. First of all, don't forget to pay for the AP exam. Lists make was an assignment from last week. You guys, last week. You guys did pretty well on it. Something to keep in mind with lists make, if we go back and look at it here, is the most common mistake was actually to do with the additional requirement I had for you to display in the beginning, the add reminders text here. Some of you did it the easier way, which would be to just set this text box to read this at the beginning of your program and then update it later. But some of you went ahead and added this to your array. The problem is if we add something to our array here, see, the add reminder should go away because it's not a real reminder, right? It'd be kind of weird to have in there. If you add that to your array, it'll stay there and then keep getting displayed. You need to correct that if you made that mistake. Moving on, we are doing loops this week. There's an assignment 050701, which is just to complete all of lesson 7. And we'll be working on that tomorrow during class, and there'll be a separate video for that. Let's take a look at a little bit more turtle programming. So I would like to demonstrate this example here. This explains or shows a demonstration of the for loop. Keep in mind, it's important to identify how far you need to go. So in this case, we start at 0. We keep going until I is no longer smaller than 2. How many numbers is that? Well, 0, 1, and then we're done, because 2 is not less than 2. So in this format, where you have I being set to 0, and then going until it's smaller than a number, you will get as many iterations as that number, in this case 2. Keep in mind that I++ occurs at the very end of our loop and means add 1 to I and store it inside I. So a lot to unpack here, but not too much once you understand the general gist of what's happening. So what does this actually do? Move forward, turn left, turn left. Well, if you turn left twice, you turn around. And move forward, move forward. So 1 step forward, 2 steps back. What will this look like if we run it? Well, we'll move 1 step forward, 2 steps back. Now keep in mind we're pacing down at this point. So the next time we move forward, we'll move down and then turn around and come back. So it's really, really important that you orient yourself the way the turtle is orienting when solving these, because it's easy to make a mistake and assume that the turtle is facing a certain direction just because you feel it should rather than because it actually is. Let's take a look at one more thing with turtle programming, and that is the fact that you might have barriers and you might have to guide your turtle through a maze. You guys set up a barrier-like system for your turtle last week, and we'll take a look at that again next class. But there is a way to check if a turtle can move a specific direction, and that is the can move function. And it'll return a true if the location you're specifying is a valid spot for a turtle to occupy. So it has to be on the grid and it has to be empty. So if we look at an example of a program like this, something like this, we have a loop here. This loop runs 3 times. Inside here, we check to see if we can move right, and if we can, we do so. We turn to the right and we move forward. Then no matter what, we will turn left next, and if the spot in front of us is empty, we'll move forward. So what does this do? We can move right, so we go this way and we face to the right. Then we turn left, facing this barrier here, and then we don't move because it told us not to. Next time we do this, we'll turn right, move forward, turn left, and since this is empty, we'll move up. Next time, we can't move right, so we'll turn left, and we'll end up facing this barrier, and we cannot move into it. So we should, in theory, end up like so. Very good. So take a look at this example again on your own. If you are not sure how I did that, you need to stare at it for a while and figure it out yourself. And then we will be moving on. There is a video here that I recommend you watch. It sums it up nicely. I'm not going to play it for you in here because the video inside of video is just crazy. And then we are going forward with the coding. So you may wish to check out Lesson 6, which is just a short overview of what loops are and what kind of programs you could write. This first one demonstrates an interesting thing you can do where the limitation on your loop, how many times it's going to run, is not determined ahead of time, but rather determined by a variable which we get from the user. So this changes how many times our loop is going to go. This other program shows that you might want to have several loops to set different things, and you can be clever about the naming of your UI elements. In this case, these are named text0, text1, and so on, so that you can use a loop to iterate through them and do the same thing to each one. Pretty clever. So please check those out, and tomorrow we are going to go ahead and work on Lesson 7, which is the practice section of loops. I hope you have a fantastic rest of your day, and I'll see you guys later.